We're so high tech. It's my great pleasure to introduce Rick Hull, who's here visiting Toronto for CASCON, and actually I'm pleased to have him give this seminar because it really does reflect the broad interests and connections between knowledge representation and between databases and between software engineering. So it's really nice to have somebody here who helps to build the ties and reinforces the interests that we have between the group. So Rick is a research staff member and manager at TJ Watson. He's been there since 2008. He's also an ACM fellow and a Bell Labs fellow. Before he joined IBM TJ Watson, he was at Bell Labs for 12 years and did a lot of very interesting research, some of it in semantic web services and personalization, which is how Rick and I first met. But he also did a lot to contribute to the product line at IBM and Alcatel, and I guess two things, Vortex and DataGrid were at least some of the things he did. But he's also well known within the research community. He was on faculty at USC, is that right? Before that, some number of years ago, he's co-author of one of the very well-known database textbooks, and he's published a lot of papers in scholarly journals. Anyways, he's talking today on semantics and verification for business entities, artifacts with declarative lifecycle, and please join me in welcoming Rick.
Thank you, Sheila. Well, I hope this talk can live up to some of those things that I did in my younger days. Let me just warn you that I did give a talk yesterday at the IBM-sponsored CASCON conference, and that was kind of very general, high-level introduction to this notion of business entities with life cycles. And actually, today, I thought what I would do is kind of a deeper technical talk. And I was here in January and gave kind of a high-level talk about business entities. So I thought for some of you at least, you've seen the general stuff, and you might be interested in just one of the details that we're working through. So I'll start out kind of generally, but then you'll see I'll get kind of specific and detailed. But hopefully it'll be interesting. This work is in collaboration with Elio DiMaggio. He's a graduate student at UC San Diego. He has some roots from the University of Rome. And by the way, he'll be on the job market, next June. And then Ricardo De Massalis, who's actually a PhD student currently at University of Rome under Giuseppe DiGiacomo. So we were able to have him visit over the summer at IBM, and then Roman Vaculin, who's at IBM. And actually, this work is really coming from a larger group at IBM Research and in Europe and elsewhere. So there's a lot of people involved with this overall activity. Let's see what the next slide is. Let's talk about this for a moment. Kind of speaking philosophically, this is a talk about business process management. Okay, so we're interested in helping businesses guide their operations in a systematic way, and be able to record what's happening and understand what's happening and potentially evolve or modify how it happens over time. There's a big separation these days between how the process side of business process management happens and how the data side of business process management is happening. Okay, the process side is modeled using something like BPMN, kind of a flowchart style or PetriNet style model. The data is modeled using database design techniques from 20, 30 years ago. Okay, and so they're kind of really operating in separate worlds, separate conceptual worlds. And what we're doing with this effort of business entities with life cycles is we're really rethinking business process management. Okay, we're saying the reason we've got processes for business process management is integrally related with the data that we're manipulating, that we're maintaining, that we're updating. So let's make the actual process model reflect data more closely. Similarly, the data that we're manipulating, we're not just manipulating generic, general purpose database data. Okay, it's not for all purposes. It's specific to business process management. So let's go ahead and think about ways to model the data that it reflects more closely the fact that I'm doing it for business process management. So we're really making a married model of process and data. That's what we're doing with these business entities with life cycles. Okay, so it's kind of a new modeling discipline, and of course it raises a lot of great computer science questions. Now that we've got this new model, how do we make it work for real world applications, and second, how do we understand it from a scientific point of view? So, okay, what is this thing, a business entity with life cycle? Okay, and I'm working with the acronym BELL for now.
How does IBM like that?
BELL?
Yeah.
Oh, as my Bell Labs roots have come out, very subtly Freudian way. Anyway, so we're combining data and process in a holistic way. Let me just give a couple of kind of just examples, from our life. So what is this thing, a business entity with life cycle? It's a key conceptual dynamic entity or object that is used in guiding the operations of a business. So it's not an entity in the entity relationship modeling style. There's much more emphasis on how that entity will evolve as it works its way through the business operations. So one kind of example would be the FedEx package delivery. So I'm not focused on the package. Okay, I'm not even focused on the waybill that you fill out at the beginning with FedEx. I'm looking at the whole delivery kind of process, the whole sequence of events as this package is, first FedEx finds out about it, they pick it up, they maybe put it on a plane, maybe they put it on another truck, they deliver it, there's a payment path, there may be some other support stuff going on about, customer care, good customers, whatever. Think of all the data and all the processing, okay, as a unit, a building block, okay? And that building block has an information model that holds. It's a logical information model. I don't care how you store it in your databases, but I want to think of it as an integrated view of all the data that's relevant to this package delivery, okay, as it evolves, as it unravels over the 2 or 3 or 5 days that FedEx is dealing with, okay? And I have a life cycle model. I have a model of all the possible ways that a random FedEx package might get itself delivered. Okay? If it's long distance, there'll be a plane involved. If it's short distance, just within Toronto, then maybe there's no planes, it's just trucks. Okay? So that I take as a unit, as my building block. Okay? So another kind of example we've had from within IBM, nice engagement was with financing. Kind of think of home mortgage. Think of home mortgage, and think of the mortgage application process, all the kind of credit checks and stuff, the approvals, finally, finalizing the deal. You could think of that as a business entity, fairly long running, 2-3 months. Okay, one entity moving through operations 2 or 3 months. In fact, with the IBM, we not only looked at the setting up the deal, but also the financing deal as it went out over 3 or 5 years. So in a sense, the particular deal entity, financing deal entity we worked with within IBM, this entity was in existence with its life cycle, okay, for 3 to 5 years. Okay, now often the business entity provides a skeleton that kind of cuts across a large swath of the enterprise, and you've got the data and the life cycle. And the data is persistent, or you think of it as persistent. Okay, so it's a way to actually understand at a larger scale how your business is working. Okay, so here's the financial deal again. Maybe there's different silos of your business that are involved in really facilitating setting up this deal. You got to do sales work to get the customer. Maybe there's some legals, there's some financial checking, etc. Okay, but this one financial deal business entity, the information model is stretching across all those silos. Okay, and then the life cycle model, okay, which could be, let's say, finite state machine, very nice. Could be based on event condition action rules. Could be using, say, Dexerflow, a declarative language for business processes. Might be more goal-driven. I mean, let's not even worry right this second about how this life cycle model is specified. Okay? But anyway, this information model provides a common vocabulary, by the way, for the people working in these different silos. So one of the big advantages of the business entity approach is the common vocabulary that's provided. Okay, now, generally speaking, you end up with, you have some scope of business operations, and you say, good, I want to model what's happening. Typically, you end up with 2 or 3 or 4 Bell types that you're working with, and maybe for a particular kind of instance of things, you might get 1 instance of the first type, and 3 or 4, maybe some number of instances of this type, and et cetera. So you kind of have this little body of these Bell instances floating around. Okay, and there's some kind of communication or messaging or synchronization between them. Okay, and as it turns out, I'm not going to go into it in this presentation, but if you just start with the data and the life cycle, you can layer several business process management aspects or components on top. Things like compliance, things like the automatic generation of the performer screens, connection to legacy applications, and several other things. Okay, now, this talk is about a project that we've been doing at IBM Research for about almost 2 years. And it's a question, the first question is, can we specify the life cycles for these things in a somewhat declarative way? Okay, most of the early work, or the first generation of work, has been on using finite state machines as the basic construct for the life cycles, or variations on finite state machines. Okay, we're interested in, an extension, an expansion, a generalization of that work. Okay, and so we're looking for something more declarative than finite state machines, something that allows us to incorporate some modularity, some hierarchy, parallelism. Okay, we want to add those capabilities to the base model that's already been worked out. Okay, if we get this declarative way, then how might we take advantage of it? What are some different ways we can take advantage of this declarative flavor of lifecycle specification? And can we support verification in this data-rich context? So these are the kinds of questions that I want to talk about, or I want to try to answer. Okay, so what I'm going to do, and I'm just going to just plow ahead here, but I'll stop for questions if people have questions. I want to introduce the what we call the guard stage milestone, or GSM approach, for specifying these life cycles. Okay. And then I'll kind of raise some verification questions that we would like to be able to answer. Okay? Then I'll talk about the formal model and the semantics. And in fact, I'm going to give you 2 perspectives on the semantics for our GSM life cycles. Okay? And then I'm going to talk about some preliminary work that we've been doing on verification for the GSM model. And it's going to turn out that we're going to be able to kind of get a reduction to some previously established results. So this will be a nice thing. And then briefly talk future directions. Okay. Any questions right now? All right. So here's a quick little example that I'm going to use to introduce the GSM life cycles. This example is got kind of a manufacturer or an assembler, okay, and what's going to happen is the client wants something, a certain kind of machine maybe, and so he's going to send in an order, and the assembler is going to figure out what are the parts he needs. It's kind of custom machine construction. He'll figure out the parts he needs, he'll send out orders to the